How to use SFC for industrial PLC automation. Imagine watching a machine perform a series of tasks perfectly timed and ordered. Now, think about how you can make that happen with a programming language designed for sequences. That's where Sequential Function Chart, or SFC, comes into play. It is a visual way to design and control processes that happen step by step in factories. SFC is part of the IEC 61130-13 standard, which is a set of rules for programming industrial control systems. It helps make complex sequences easier to understand and manage. To start using SFC in automation projects, first learn about its main parts. The key components are steps, transitions, and actions. Steps are like stages in a process, such as filling a tank or turning on a motor. Transitions are the conditions that tell the system when to move from one step to the next, like a sensor detecting a full tank. Actions are tasks that happen during each step, like activating a valve or starting a timer. Next, you need to plan your sequence. Begin with an initial step, which is usually marked with a double-lined square. This is where your process starts. Then, add other steps as single-line squares, each with a clear name. Connect these steps with transition lines, which include conditions that must be true for the process to move forward. For example, a transition might depend on a sensor reading or a timer reaching a set value. Once you have your sequence mapped out, you can program it into your PLC using software that supports SFC. Popular options include Siemens PCs 7 or LS Electric XGB PLC programming environments. Drag and drop the steps and transitions onto the programming interface, then assign actions to each step. Make sure to set the transition conditions based on real sensor inputs or internal variables. This way, the PLC knows exactly when to switch from one step to the next. Handling more complex processes is simple with SFC. You can create parallel branches to run multiple steps at once, which is useful in assembly lines or robotic operations. You can also set up conditional branches, so only one path is taken depending on specific conditions. This flexibility makes SFC ideal for controlling intricate manufacturing sequences. Safety and fault monitoring are also important. You can program the SFC to constantly check for faults or errors. If a problem occurs, the sequence can automatically stop and bring the system to a safe state. Manual stops are also possible, allowing operators to intervene when needed. This ensures the process can be resumed smoothly after any interruptions. Finally, testing your sequence is essential. Use simulation tools within your programming software to verify everything works correctly before running live. Watch how the steps and transitions behave and make adjustments as needed. During actual operation, monitor the system to fine-tune timing and conditions for optimal performance. Using SFC in industrial automation makes controlling complex sequences much easier. It helps you visualize the process, troubleshoot quickly, and maintain the system more effectively. Whether you are managing assembly lines, batch processes, or robotic tasks, SFC provides a clear and reliable way to program your control systems. It aligns well with Industry 4.0 trends by making automation more transparent and adaptable.